All right, so the next lesson in the geometry unit is on something called on parallel lines. Okay, so this is section 2.1 slash 2.2. All right, parallel lines. All right, so first thing is whenever you see two lines that are parallel means that they'll never cross. To show or indicate that they're parallel, you'll see arrows. Okay, so arrows are in the same direction. Okay, so whenever you see these two arrows on a diagram, it's indicating that the two lines are parallel. So they're lines that go on forever that will never, if they were to go on forever, they would never cross. Okay. Now, with parallel lines, what we can do is though we can create a bunch of angles with once we draw a line that crosses these parallel lines. Okay. Now this line here has a name to it. It's called a transversal. Transversal. All right. So that's whenever you have a line that crosses two parallel lines, it's called a transversal. And so what ends up happening is it creates a whole bunch of angles, right? So let me just number some of these off. So that's 1, 2, 3, 4, 5, 6, and 7, 8. All right. Now, with these, with the parallel lines and a transversal, we can see that there are some angles, and some of these angles turn out to be equal to each other. All right. So first set of angles that I want to show that are equal are these two angles here, angles 3 and angle 6. Okay, so these two angles will be equal to each other. You can kind of see that perhaps they kind of look like they're equal. As long as these two lines are parallel, you have a line that crosses, they will be equal. All right. Now the way you memorize or remember this property is that with the letters that the angles create. So notice that if I trace angle 3, right, let me get this here, and then if I trace angle 6, I get this angle here with this line. All right. So if you follow this line here, you can see that it created the letter Z. All right. So Z angles are equal. Okay, so in other words, in this diagram, angle 3 is going to equal angle 6. All right. Now with Z angles, they don't actually have to be the letter Z. They can be backwards as well. All right. So if you kind of see here, let's draw use a different color here. First, let's figure out the red. All right, so I'll attempt to put some blue there. All right, so let me draw that. The arrows again too. All right, so just give me one sec here, guys. All right, so these two lines are parallel. And let's just draw that transversal again. Not the straightest of lines, but anyways, there's a transversal there. The other set of Z angles, even though it doesn't form the letter Z, would be angle 4 and angle 5. Okay, so if I trace angle 4, this angle, if I trace angle 5, notice how it's connected. This form I guess it's kind of like the letter S. It's a backward Z. Right? So we have two sets of Z angles. Angle 3 and angle 6 are equal, and angle 4 and angle 5 are also equal. Okay. These are called, terminology-wise, these are called alternate interior angles. Okay, so yeah, so whenever you have two angles that form the letter Z or a backward Z, which is an S, those two angles will be equal. So that's the first set. The best way to memorize these things is, by remembering the letters. Okay, so just remember two angles that form the letter Z, as long as the top is parallel to the bottom, they will be equal. All right, the next set, so I'm just going to draw the parallel lines again. Maybe transversal. All right, we just want to number these off again. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's some other angles that are going to be equal. All right, so the next one I want to show is angle 4 here, and angle 8. So if I trace angle 4 all the way down here, angle 8 as well, you notice that they create the letter F. And these angles are also equal. Okay, so see how this, the angle 4 here and angle F, or angle 8, when I trace it, they create the letter F. Okay, therefore angle 4 is going to equal angle 8, as long as these two lines here are parallel. Okay, so angle 4 equals angle 8. All right. And just like the previous one there with the Z's, the F themselves can be backwards, it can be upside down. All right, so I'm just going to see this. I'm going to erase this. Good. All right, so let's just draw that transversal one more time. Oops, that was terrible. All right, so there's a transversal. So angle 4 and angle 8 are equal as well. Let's go with angle 1 here. Angle 1 and angle 5 are also equal because this creates a upside down F. Okay, so angle 1 is equal to angle 5. You know what? Rather than erase, I'm just going to use different colors here. Another set here. Angle 2 here and angle 6 are also equal. They create an upside down and a backwards F. And so angle 2 is equal to angle 6. And likewise, angle 3 is equal to angle 7. So let's just use a different color here, purple. All right, so angle 3 here, angle 7. All right, so that creates a backwards F. So that's all. Those angles are also equal. Okay, so in this case, we actually have 4 sets of F angles. Right? So again, angle 1 is equal to angle 5, 2 is equal to 6, 3 is equal to 7, and 4 is equal to 8. Right. Now, the third property that I want to show you is another letter. Right? So again, let's create transversal. As it turns out, 1, 2, 3, 4, 5, 6, 7, 8. There's one more letter we can actually create with these angles. Right? So angle 4 and angle 6 create the letter C, right? You guys see that? Now C angles, you can. It's pretty obvious that they're not equal, right? Because this one's bigger than 90. This one's less than 90. Okay, so they're not equal, but they add to 180 degrees. Okay, so angle 4 here plus angle 6 is going to add to 180. All right, and this letter C can also be backwards. So angle 3 plus angle 5, if I add those together, that's also going to be 180 degrees. All right, so again, so if I list these off, angle 3 plus angle 5 is equal to 180. And angle 4 plus angle 6 is also equal to 180. Okay, so just be careful about C angles. If they form the letter C, they're not equal, right? But they do add to 180. So that is a property. Whereas F angles, notice that there's 4 of them here. Whether it's backwards, upside down, and backwards, those are equal to each other. And Z angles, or alternate interior angles, and here there's 2 sets of them. Those are equal as well. Okay, so that's just kind of a summary of some properties. Now, what I'm also going to do here is I'm going to go through an example. Now, going to your package, all right, so we did this in the last lesson, the basic angle properties. Now, the next page here, the first page here, basically, this sheet here just summarizes what I showed, all right? So alternate interior angles, Z angles. So angle 4 is equal to angle 7, angle 3 is equal to angle 5. Okay, so these can be backwards. Corresponding angles are equal, so F angles, so 3 and 8, 4 and 6, 2 and 7, 1 and 5. Okay, and interior angles on the same side transversals are supplementary, so that means add to 180. They're C angles. Okay, so 3 and 7 add to 180. That does 4 and 5. Okay, so this page here just summarizes what I kind of just went through. Okay. So what I'm going to do here is I'm going to take an example, take one of these pictures. Do that. I did cut and paste this one here. So let's look at that. Sure. Okay, so this again, this diagram here is the same as this diagram right here. Okay, cool. All right, so let's see what happens. Let's work through this. So basically, what we're going to do here is I'm going to work this kind of in order. All right, so angle 1, then 2, then 3, and 4, and then 5. So starting off with angle 1, starting off with angle 1, let's just see if there is a way we can figure out what this angle is. Okay, so this angle here. This angle here is 22 degrees. However, there's no box here, so this is not 90 degrees. Okay, so we can't assume it's 90, so we can't do the complementary rule. But what can we do here? Okay, so angle 1, if you look here, there's a big triangle. So we're going to use a property from the last lesson. So you can see this triangle here. That angles in a triangle add to 180. Okay, so if I take 180 and subtract 73, subtract 40 degrees, this should give me angle 1. Okay, so angle 1, I'm trying to attempt to do that in my head here. 180 minus 73 is 107. Minus 40 is 67 degrees. All right, so let me just make sure I get that right. I just going to double check. I'm just going to add 67 to 73, so that gives 140 plus 40. Yep. All right, so these three here, 180 minus 73 minus 40 gives me 67 degrees. All right, as well as you work through this, it's a good idea to fill in the angles into the diagram as you find them. Okay, so angle 1 there is 67. All right, so now what I'm going to do here is I just find that red mark a little bit distracting, so I'm going to erase this. All right, so that's 67 degrees. All right. Next up, I want to find angle 2. Now, here's a hint that I find helpful is that what I do is I kind of trace the angle that I'm looking for and just see what happens if I extend that line. Right, so I extend that line down this way. You can see that it does actually hit angle 1. Right? This angle 1 is connected to angle 2. And you can see here, this is a Z angle. The two lines, the top and bottom, are parallel. So I can assume that they're Z angles, and remember, Z angles are equal. All right, so angle 2 here turns out to being 67 degrees as well. Let's just fill that one in. All right, well, we're getting somewhere. Let's see angle 3. Okay, so angle 3 right here. Again, I'm going to do the same thing. I'm just going to trace it and see what happens. Notice that goes all the way down to here. So this creates a backward Z, or in other words, a letter S. So these two angles, angle 3 and the 40 degrees, must be equal. Right? So therefore, angle 3 here is 40 degrees. All right. Oh yeah, and as we work along here, we can just kind of cross these things off. All right. So next up, angle 4. So this angle right here. Let's just see what we can do here. Actually, I'm just going to erase these lines here. A little bit distracting. All right, so angle 4. Let's see, what can we do here? Find this here. Okay, so see that we have a triangle here. So it's possible for me to find this angle here, right? Because we have angles on a line. So if I take 180 and minus 73, this will give me 107. Right, so this is 107 degrees there. So therefore, angles in a triangle add to 180. Right? So these three angles, angle 4, the 107, and the 22, must add to 180. Okay, so therefore, angle 4 is going to equal 180 minus 107 minus 22 degrees. All right, so what is that? That is 73 minus 22, which is 50. No, I feel like I did for more. Let's just pull out a calculator. 180 minus 107 minus 22. All right, gives me 51. Oh, so it's 53 there. All right, I'm going to double check with one more thing here. So I did get 51 there. Just check if yeah, so it's not 53. One sec here. I'm going to do another property here just to double check, and I'll just show you in green what I'm going to do here. This big angle here and this angle here, this creates, you can see that creates a C angle, right? So what that means is that if I take the 22, add it to the 67, and the 40, right? If I take 180 minus those three angles, I should get angle 4. Which will see what that gets us. Right? It's 180 minus 40 minus 22 minus 67. We got 51 degrees again. Okay, so angle 4 is, I might have cut off actually the answers here. So this is 51 degrees, angle 4. So this is 51 degrees. Last angle, this angle here, so angle 5. We can do the same thing, right? So this is 107, this is 107. So let's do 180 minus, so angles on triangle add to 180. So let's go 180 minus 107 minus 30. All right, so we do get 43 degrees. All right, so it appears that this answer here is incorrect. It should be 51 degrees. All right, cool.